What were the concepts that we discussed? Ready? So we'll just come from the top. Let's see what we have discussed. So in the previous class, those were all in our together. What did he type there? Yes, sir. Okay. Right. So yesterday we discussed the concept of introduction of wave optics. In introduction of wave optics, I told you there are two important points to be remembered. What are they? One is a term called as wavefront, and under wavefront we saw three different types of wavefront. Right. So what is a wavefront? Wavefront is a locus of all points which are vibrating in the same phase at that instant of time. Is that right? Then how do you draw the wavefront? By taking a particular distance, depending on how the source is present. If it is a point source, what the shape of wavefront you are going to get? It is going to be spherical. When it is linear, you get a cylindrical wavefront. And when it is a point source, which is at infinity, when it is a source at infinity, you get plane wavefront. Right? And the next concept that we saw was about rays. So what is a ray basically? It is an arrow mark that is drawn perpendicular to the wavefront to what? Find the direction in which the wavefront is actually propagating. Right? So these were the two important concepts that we discussed. Right? So we have completed. Right. So the next concept that we are going to discuss is Huygens principle of secondary wavelets. Please make a note of it. The next topic is Huygens principle of secondary wavelets. Right? Now I want you all to concentrate on one thing. If you see, Huygens is a famous scientist. So that scientist has proposed a principle, right? Related to what? Related to something called as secondary. If you see the next term, it is not wavefront. Rather, we are using the word called as wavelet. Right? So what is the difference? That's what we are going to see. Okay. So I want everybody to concentrate. This is a slightly tricky concept. Okay. So concentrate on this. What are the two words we are going to discuss about? One is wavefront, which we already know. Now we are going to see what a wavelet is. Okay. There is a slight difference, and we'll see what it is. So, if you see the first point that is to be noted is Huygens principle is the basis of wave theory of light. Yesterday we discussed about the different theories that were proposed with respect to light. First, we started with the corpuscular theory, then came the concept of wave theory. If you see, though Young and Fresnel, they were the first one to prove that light had wave nature through an experimental aspect, but it was first proposed by Huygens. That is why it is credited as Huygens principle is the basis of wave. Okay, what did he propose? First, it mainly speaks about how a wavefront is propagating through a given medium. Right? So, irrespective of whether it is a spherical wavefront or a cylindrical or a plane wavefront, they are going to propagate. And this principle mainly speaks about in what manner the wavefront is actually going to propagate in that medium. Means how it is going to travel in that medium. Right? So here comes an important point. This is the first step. So according to this principle, right, each point on a wavefront, I repeat it, each point on a wavefront acts as a source for secondary waves, right? And those secondary waves add up to give a wavefront at any other later time. The meaning of this is, let's say I have a point source, and this point source will generate a spherical wavelength like this. Now read the statement carefully. If I call this as the first wavefront that is generated by the point source, each point on this spherical wavefront will start acting as a source for the new disturbance. Meaning, I can say that this wavefront is made up of infinite number of such points, which are in turn producing individual wavefronts. Meaning, around this point, I can define a wavefront. Around the second point, I can define a wavefront. Around the third point, I can define a wavefront. Around the fourth point, I can define a wavefront. Means those are virtually produced. That is what we are saying. According to Huygens principle, this is the red one is the first wavefront that is generated by whom? Generated by the point source S. So each point on the wavefront that is generated by the source S will start behaving as a source for the secondary waves. Then how are those secondary waves actually generated? By adding up all these values. So how are we going to add? We'll go to that next. See. So this principle is mainly based on two assumptions. The first assumption that we are going to talk about is the same point getting repeated. Each point on a wavefront acts as a fresh source of new disturbance called secondary waves or wavelets. Note this point. The source has produced a red color curve, right? That red color curve is called as wavefront, generated by whom? By the point source. But these points which are there on the wavefront are acting as a source for secondary wavelets. So these black color curves that we have drawn here are actually not wavefronts. They are called as wavelets. So you need to do something with respect to these wavelets to get the new wavefront. So in this context, I am going to use red for wavefront and black for wavelet. Am I clear till this point? So I hope this point has got registered. Each point acts as a source for or a fresh source for new disturbance, and those new disturbances that are getting generated are called as secondary waves or wavelets. Right? Now the question is, how are these secondary wavelets going to travel? So the secondary wavelet spreads out in all the directions. Like if you see the way I have drawn, they're symmetrical. So they start getting spread out in all the directions symmetrically. And with what speed are they going to travel? They are going to travel with the speed of the light in that particular medium. Okay, that's what is mentioned here. The secondary wavelets spread out in all directions with the speed of the light in that given medium. If it is air medium, it is going to travel with the speed of 3 to 10 power 8 meters per second. If it is glass medium, it will be something else, depending on what the value of speed in that medium is. Are you guys able to understand? Right? And the third important point is the new wavefront. So yes, I have drawn the wavelets, but how am I going to get the new wavefront? By look at it. The new wavefront at any later time is given by the forward envelope. So here forward envelope means the tangential surface that you're going to plot to these wavelets in the forward direction. So if you draw a tangential surface to these wavelets, then you will get the new shape. And that new shape is the second wavefront that is generated by the first wave. Right? So how is it going to look like? It will be something like this. Right? So I have drawn the tangential surface. So the tangential surface to the secondary wavelets will generate the new wavefront. I hope these 2 points have got registered in your mind. Right? Now you can make a note of it. Clear? So let me know once you're done. So I just want to make another note here. This Huygens principle, these three assumptions are there, no? They are also called as Huygens construction. Okay. For example, in your geometry, let's say I'm asking you to draw a perpendicular bicycle. Okay. Simplest way is what will you do? You will take a scale, measure the midpoint, and draw something perpendicular using protractor. But I say draw the same thing using a compass. Right? You follow certain steps for the construction. Right? First, you draw the line segment, then you will cut an arc greater than half of the length, and then join them. Right? So, in a similar way, for you to frame the new wavefronts that is generated due to the individual wavefronts, we need to follow these three steps. Okay, that is why it is also called as Huygens construction. It is something similar to mathematics. I hope you're able to understand, right? So based on this Huygens construction, we will be able to prove the theory of loss of reflection and the loss of refraction as well. Okay, about which what I would suggest is, I have already done a video based on. First, go through that and come because it will be simpler as I've drawn everything in the top. Okay, so you'll be able to see how much measurement to be taken and then you will be able to construct it. So for today, you can have a look at it and come. And tomorrow's class, if there is any doubt, I'll explain. So I'm going to the next important concept, that is principle of superposition. Right. So the next heading that we are going to discuss is principle of superposition of waves. I hope this concept is not new to you, right? So we have been discussing about this many times. So even before we see the statement, can someone state it? So what does principle of superposition mean? So it has something to do with addition. What addition are you talking about? Are you doing, see, when you say addition, right, you're going to talk about two additions. Algebraic or vector? Most of the cases you see there's vector addition. Because you do this addition for displacement. What is displacement? Is it a vector or a scalar? It's a vector quantity, right? So mostly we'll be following the vector addition again. See, it's very simple. Even before I explain this, right, I would like to show you a small simulation. So if you look at this scenario, let's say you have this as the water. It's a still water, correct? So in the still water, if you're going to create a disturbance, so when I say disturbance, what kind of disturbance you can create? You can take a small stone, just drop it, or you can take the help of another water droplet. That is why there is a tap which is kept here. So let's say this tap has a problem and there is some leakage. Okay. So each drop is falling into it. What is going to happen? So you're able to see something like this. So what are these actually? Ripples, right? See. So yesterday I told you, right? When you see it from the top, how will it appear? They will appear as if they are longitudinal waves. Did I tell this? Yes. So when you see it from the top, it looks like concentric circles. Whereas if you go exactly in the lateral view, then how is it going to appear? I told this, right? When water is dropped, you have a brisk and a drop. So this is how the wave is going to get traveled. Again, from the top, it is going to be a set of circular concentric circles. Is that right? No, I have a question. Okay. So till here we didn't have any problem. It's a smooth process, accepted. Suppose I introduce two drops. Okay. Suppose I introduce two drops, then what is going to happen? See if you're, what are you able to see? So here there is a disturbance, here there is a disturbance. They both are actually getting mixed up, added at certain points and subtracted at certain points. Is that right? So if I take this water and exactly convert it to light, okay. I mix it everything. Yeah. So suppose, let's say there is a point source. Then that point source is going to release the light in the form of what wavefronts? This will be discussed. It is going to release in the form of spherical wavefronts. Am I right? Now the question is, if I introduce an other source, see what is happening. So what is happening? So this wavefront and this wavefront are getting merged on top of each other, accepted? So when they're getting merged, are you able to see certain spots which are bright? Means the intensities are getting added, and there are certain spots at which the intensity is getting subtracted. Means it is completely dark. Are you able to see some dark portions? Right. Now I have a question. Okay? I want you all to think and tell. So I'm setting everything. Switch it off. Okay. Now I'm going to place a screen here. This black color part is a screen. Let's say there's a point source. If I switch it off, you saw that spherical wavelengths are coming out. Then what do you think you can observe on the screen? So where will you find it? Is it going to be completely bright? Or is it going to be bright only at this spot? Completely brighter. Why? Yesterday I told you this. Because it depends on intensity area. Let's see. What is happening? It is bright at every spot. Though it is a point source, it is bright at every spot because I told you about the concept of diffraction yesterday. It's not about the wavefront concept. Yesterday I told you what does light have, what property does light exhibit. In this context, it is exhibiting the property of a wave. So waves exhibit what property? They exhibit diffraction here, right? But here it's not diffraction that I'm trying to talk about. It is basically scattering that is happening. Right? So it is going and falling on the screen. Okay, no doubt about this. Okay, I'm pausing this scenario. Now I have another question. So previous scenario I showed you, right? If I introduce another source, you had a set of bright spots and dark spots. Now, when I introduce another source, what is your expectation on the screen? When I do completely brighter. That's the logic. Right? That's the logic, right? It should be completely bright because they are adding more light. Is that right? What is happening? There are certain spots which are bright and there are certain spots which are dark. Are you able to understand this? So what is actually happening? If you try to give a theoretical explanation to this, see there are different experimental setups that are to be followed for this. That is a different story. But as of now, I am saying if there are two light sources which are kept close to each other, and I keep a screen also which is closer to each other, right, closer to the whole source, then you can find this kind of a pattern. And this kind of a pattern is called as interference pattern. Okay, so if you see what is interference, interference is basically superposition of two waves that are coming from two different sources. It will happen, but you will not be able to see. Because what do they say wave optics is? It is a branch of physics where you deal with objects whose size is comparable to the wavelength of light. Whereas when you talk about headlights and other things, it's a macroscopic. That is when it happens, but you will not be able to see. Okay. But here it is more specific because this experiment itself is designed for this purpose. Okay, this one you can actually call it as this is completely not X double slit. So I'm going to talk multiple points. Listen to this carefully. So if I add something like this, so slit is basically an opening. So look at the way I'm actually diverting it. Can you observe the difference? Right. Previously you had set of concentric circles, but if you see now what is happening, this wavefront is actually going and hitting the surface and again getting bent. Right. This bending pattern after it strikes an obstacle is called as diffraction. Okay. And this opening is called as slit. So how many slits are there? One slit. So if I add one more slit, it becomes. So slit is basically an opening. So if I add two slit, this is what is the experimental center of something called as Young's double slit experiment. Okay. So to put the whole story in one line, this is all we are going to learn. Okay. So for us to understand this Young's double slit experiment or the concept of diffraction, the first preliminary point that we need to understand is principle of superposition of waves. I hope you are able to visualize what is the superposition. Am I right? So this is what we are going to mathematically. So is there any doubt? Clear? So coming back to this point, so write down the heading as principle of superposition of waves. Okay. The first point is when you have a number of waves, the number can be anything here. In the example we took, but you have multiple rays, let's say. When a number of waves are traveling through a medium, right? That medium can be anything. Okay. When they are traveling through a medium, superpose on each other. What do you mean by superpose? When they come in contact with each other, they superpose on each other, then you have something called as a resultant. What is resultant? It is the outcome, right? So the resultant displacement at any time, at any given instant is equal to whom? Is equal to the vector sum. Point to be noted here is equal to the vector sum of the displacements due to the individual waves at that point. You need to understand what I'm trying to say. For example, in the simulation which I showed you, you had a source here. Let's say that is treated like a wavefront, but it is generated from the wave only. So it will have a mathematical equation. Let's say the displacement of that wave is y1. And let's say the displacement of the second wave is y2. So how many individual waves you have in this scenario? You have two. So when I say when a number of waves, in this scenario you have two. When two waves are traveling in the medium, right? When they superpose on each other, what will happen? The resultant displacement at any instant, at any given point of time, at any point, at any instant, is going to be whom? The vector sum of the individual displacements which are participating in the superposition process. Is that clear? So how you write it mathematically? Suppose if y1 vector, y2 vector, y3 vector, so on till yn vector are the displacements due to the different waves acting separately, then according to principle of superposition, what can you say? The resultant displacement, if I call it as y, then y will be equal to y1 vector actually, yeah. So it should have been y1 vector plus y2 vector plus so on till yn vector. So they get added vectorially. They don't get added algebraically. Is that right? So this is the mathematical expression. Keep writing, I'll be back. Can I proceed? Shall I proceed? Those who are online, are you able to understand?
Yes, sir.
Moving to the next point. So you can actually make a note of this. I'll go with mathematics. Okay. So when the two superposing waves are in the same phase. So you know what is phase? No, phase is basically angle. Let's say there is a crest and there is another crest. If they superpose on each other, what will happen? Since principle of superposition says it is a sum of individual displacements. Okay, this is having a displacement of A, and this one is having a displacement of A. If these two waves superpose on each other, then what is going to be the resultant intensity at that point? It will be A plus A, right? So when two superposing waves are in the same phase, even in the same phase, if the crest of one falls over the crest of another, or the top of one falls over the top of another, their displacements get added. So when the maximums in the upward direction get added, the intensity becomes maximum in this slide. Whereas in this case, here also they get added, but the intensity will be maximum in the opposite direction. Okay. When the two waves meet in opposite phases, what do you mean by opposite phases? One is having maximum intensity, other is having minimum intensity. So this will be A and this will be minus A. So A plus of minus A will give you an intensity of 0. That is why when you saw that screen thing, right, you had some dark spots. So at that spot, what has happened is the maximum of one wave superposed with the minimum of another. Whereas wherever you had a bright spot, what happened? The maximum of one was coinciding with the maximum of second. Are you able to understand? Right. So based on this, I already explained you the concept of interference of light. Right. So write down the statement for it. So everything is the same. It's like the principle of superposition remodified in different ways. Right. So interference of light mainly speaks about superposition only. But here an important point to be noted is when I spoke about principle of superposition, I never mentioned the direction in which the waves are supposed to. Did I say that? Check your rules. When a number of waves are traveling in a medium, that's it. I never mentioned direction. Whereas if you read the statement, right, when you have to talk about interference, let's say you have two light waves, right? The first point to be noted is interference. Here we are talking for two light waves, and the most important point is they should be of the same frequency. Repeat, they should be of the same frequency, or it should have, they should be of the same frequency and they should have 0 or constant phase difference. So they should have 0 or constant phase difference. And the most important of all is they should travel in the same direction. Okay. So unlike the statement of principle of superposition, here the point we are going to concentrate upon is the two light waves should have what? Should have the same frequency and 0 or constant phase difference, and they should travel in which direction? In the same direction. If those two light waves are able to superpose on each other, then there will be different regions where the intensity will vary. Okay. So what the statement says is the intensity in the region of superposition gets redistributed. What do I mean by redistribution is some spots are bright and some spots are dark. So bright spots you can, yes. So bright spot you can say that the intensity has got added up, and dark spots you can say that the intensity has got nullified. Right? So superposition gets redistributed, becoming maximum at some points and minimum at others. And this kind of a phenomenon, why do we call it as phenomenon? Because you see it. So something which you can see is called as a phenomenon. So this kind of a phenomenon is called as interference of light. Am I clear with this? Right. So first make a note of this statement. Right. So here I want to make another important. Okay. I want you all to note down this one. You all finished writing? See some of your writing. Shall I proceed? Shall I proceed? Okay. So I told you, right? When two light waves of the same frequency and having zero or constant phase difference, these kind of waves which follow this pattern are said to be coherent in nature. Make a note of it. They are said to be coherent. So what do you mean by coherence, guys? When do we say two light waves are coherent? When they have the same frequency and zero or constant phase difference. That kind of a scenario exists. We call them as coherent in nature. Right? If those coherent light waves are traveling in the same direction and they superpose, then you will be able to observe a phenomena where what gets redistributed? Intensity gets redistributed, and that kind of a phenomenon is called as interference of light. Have this in your mind. Now we are going to get into mathematical terms. Okay. Shall I proceed? Suppose so write down the heading as condition for maxima and minima. Condition for maxima and minima. Okay. Suppose I have a light wave whose displacement, okay, is represented by the equation y1 is equal to, let's say, a1 sine omega 1t. Listen to this, then you can write. And y2 is equal to a2 sine of omega 2t plus y. Okay, let's say these are the two light waves, okay, which are traveling in the same direction. Okay. If they are going to superpose, what they say, these are the two light waves which are traveling in the same direction, and they are going to superpose, then you will be able to observe a pattern called as interference of light. Are you in acceptance with me? Right? But I am contradicting. It will not happen. Phase difference is constant. Concentrate on something else. Concentrate, find the mistake. Say phase difference is constant because omega 2t plus y and omega 1t. Suppose you look at them. If you have to find the phase difference, right, it is going to be phi provided omega 1 and omega 2 had been this. Okay. First of all, in this case, it is not possible for us to define the interference. What am I supposed to do? I need to write them in this way. So y1 is equal to a1 sine omega t and y2 will be a2 sine of omega t plus y. Am I right? Now what is the phase difference? Omega t plus y minus omega t. How much is the phase difference? Phi. Phi is a constant because it's not a function of time. See, how will I know whether it is a function of time or not? Omega into t is also phi only. So observe this. Omega into t is also phi. Phi is basically angle. Phase is angle, right? But if you see omega into t, is it dependent on time or not? Yes, it is. So omega into t is not a constant. But if I simply write it as phi, which is not a function of time, then it is going to be a constant. So the waves would have either been y1 is equal to a1 sin omega t and y2 is equal to a2 sin omega t. Had it been in that scenario, then the phase difference would have been, listen to my question carefully. Had it been y1 is equal to a1 sin omega t and y2 is equal to a2 sin omega t, what is the phase difference? 0. Whereas in this scenario, what is the phase difference? Phi, which is a constant, right? If these two waves are traveling in the same direction, let's say they are traveling in the same direction, then y will be equal to y1 plus y2, which implies y is equal to, observe. So what does principle of superposition state? Y vector is equal to y1 vector plus y2 vector. But here I didn't write it in that form because I already mentioned that they both are traveling in the same direction. So vectorially they are going to have the same sign. Right. So I directly took the algebraic sum of them. So y will be equal to a1 sin omega t plus a2 sin of omega t plus phi. Okay. Now look at it. Y will be equal to a1 sin omega t plus a2 into sin of omega t plus phi. That is sin of a plus b can be written as sin a cos b plus cos a sin b. So it is going to be sin omega t cos phi plus cos omega t sin phi. Right? Right. Now if you take out sin omega t outside, it will be a1 plus a2 cos phi. Right. If I take the sin omega t outside, it will be a1 plus a2 cos phi plus a2 sin phi times cos omega t. Am I clear with this? So here if you observe it, this particular expression is a combination of functions of time and constants. So sin omega t is a function of time, whereas a1 plus a2 cos phi is a constant. Similarly, a2 sin phi, a2 is a constant, sin phi is also a constant. So a2 sin phi is a constant, but cos omega t is a variable. It's a time varying function. So when you observe this, I am going to take these constant and assign them to a new variable. So observe what I am doing here. If I take this as 1, then I will write a1 plus a2 cos phi is equal to some other trigonometric constant, which I will call it as capital A times cos theta. Similarly, a2 sin phi will be equal to, I'll call it as capital A sin theta. If I do that and take these two values and substitute it in equation number 1, then how is my expression going to get converted as? Y will be equal to, in the place of sin omega t, I leave it as it is. Right? So a1 plus a2 cos phi can be replaced as a cos theta into sin omega t is as it is, plus a2 sin phi can be replaced with a sin theta into cos omega t. Right? So if I take out a common from both, then I'll get sin omega t cos phi plus cos omega t sin phi, which I can write it as y is equal to a into sin of omega t plus t. Small correction. And write it again. So if I take out a common from both, then y will be equal to a sin omega t cos theta plus cos omega t sin theta, which can be ultimately written as y is equal to a into sin of omega t plus, and this y is equal to a sin of omega t plus theta is what is going to be the resultant displacement of the final wave that is formed. And we need to define the redistribution of intensity with respect to the sphere, which I'll do in the next slide. The meanwhile, copy this. I'll do that. That's what I told you. That's what I told you. I'll go to the next step. Let me know once you're done. Better. So suggest just go to the execution and write right now. Directly off. Next. Better. So now we understood that when these two equations of two different forces are considered, which are coherent in nature and traveling the same direction, the final expression that we got is y is equal to a sine of omega t plus theta. If you observe in this expression, a is a parameter which was not given here, it is being introduced. Similarly, theta is also a parameter which was introduced by us. So now it is our job to write the value of a and theta in terms of a1 and a2 and phi. Okay, so we will see how to do this. For that, since a1 plus a2 cos phi is considered to be a cos theta, and a1 sin phi, a2 sin phi is considered as a sin theta. Now, if you observe, if I have to eliminate theta, Right? According to the basics of trigonometry, we know that we need to square them and add them. If I do that. So if I square on both sides, I get a1 plus a2 cos phi the whole square is equal to a cos theta the whole square. Similarly, if I square this, I'll get a2 sin phi the whole square is equal to a square sin square. Right? So here what do I have? I have a square cos square theta, which is a1 plus a2 cos phi whole square. So a square cos square theta, if I add it to a square sin square theta, I'm going to get a square. And the left hand side will be an expression in terms of a1, a2, and phi. A2 and phi. Let's see. When I add, let me call this as 2 and 3. When I add second and third equation, I will get a1 square plus a2 square cos square phi plus 2 times a1, a2 cos phi. Right? Plus a2 square sin square phi will be equal to a square into cos square theta plus sin square. And this value is going to be equal to 1. Right? So what will I get here? I'll get on the left hand side, I'll have a1 square plus, if I take this a2 square common from both, a2 square common from both, I'll get a2 square into cos square phi plus sin square phi plus 2 times a1 a2 cos phi. I can consider it to be a square. So what is going to be the value of a? Obviously, it is going to be the square root of. So a will be equal to square root of a1 square plus this cos square phi plus sin square phi is 1. So a1 square plus a2 square plus 2 times a1 a2 cos phi. And this is going to be the value of the resultant amplitude in terms of the given individual amplitudes. Right? So if you look at this expression, is it not similar to the resultant of two vectors in parallelogram? So R is equal to root of a square plus g square plus 2ab cos theta. There's something similar. Right? Though they don't convey the same context here because we are not dealing about the vectors in random directions. Right? So let me complete the next point also, then you can write it. And similarly, I know that a sin theta, from here I know that a sin theta is equal to a2 sin phi and a cos theta is a1 plus a2 cos phi. So in the previous scenario, what we did is we squared and add them to eliminate theta. Now if I want to eliminate a, so what I do is I divide. When I divide a and a are gone, so here also you divide. So left hand side you have tan theta is equal to a2 sin phi divided by a1 plus a2 cos phi. So theta will be equal to tan inverse of a2 sin phi divided by a1 plus a2. So this will be the value of theta in terms of a1, a2 and phi. Clear? So make a note. Clear? Then proceed. Yes, sir. So this is the expression for resultant amplitude. And this is the expression for resultant phase. Right? Or the phase of resultant modules. But the question here is, if I go back to the basics of interference of light, what is the statement telling us? It's telling that if two light waves which are coherent in nature are traveling the same direction, they superpose in such a way that the intensity is redistributed. Right? Nowhere in this context we spoke about intensity. We were speaking only about amplitude. Right? Now comes an important point. That is we know that intensity is directly proportional to square of the amplitude. So intensity is proportional to square of the amplitude. And we know that A is equal to root of A1 square plus A2 square plus 2 times A1 A2 cos theta. Sorry, cos phi. Right? Cos phi, where phi is the phase difference between the initial waves. Right? Now, if I square on both the sides, I get A square is equal to A1 square plus A2 square plus 2 times A1 A2 cos phi. Are you an acceptance with this? Another question is, can I replace A square according to this expression? Can I replace A square with intensity? Right. So basically, what is going to happen? I is directly proportional to A square. So I can write I is equal to some constant times A square. That's it. So if I write constant on both the sides, the constant is going to get cancelled. So I'll have I is equal to this. I can write it as I1. So what is I? I is the intensity of the resultant. Intensity of the resultant is equal to intensity of the first wave plus intensity of the second wave plus 2 times A1 will become root of I1. So 2 times root of I1 into root of I2 times cos phi. So can I say that this is going to be the intensity of the resultant? Right. Now we need to concentrate on an important point. This is where I'm going to start framing conditions where you have bright spots and framing conditions where you have dark spots. Okay. Now, if I look at this expression, what are all constants? This intensity is not a constant because it is a function of some other variable on this. I1 is a constant because I1 is dependent on the amplitude of the first wave. I2 is a constant. It is dependent on the amplitude of the second wave. In a similar context, root of I1 and root of I2 will also be a constant. What changes this? Phi. Right. So why I'm talking about the phi here is it can take different values. Right. So when it is taking different values, we need to find out those values which will give us the maximum intensity for the resultant. Right. So if I look at this expression, when can I say this intensity is going to be maximum? Since the deciding factor is cos phi, whenever cos phi is going to attain the maximum value, this intensity will also attain the maximum value. So for intensity to be maximum, listen to this carefully. For intensity to be maximum, can I say cos phi is supposed to be equal to the maximum value of it? What is the maximum value of cos?
1.
Maximum value of cos is 1. So if I say cos phi is equal to 1, what are the values that phi can take? Here, concentrate. You should not write a particular solution, rather you should write a general solution. So if I say particular solution, you will say phi is 0. But what is the general solution?
N pi, sir.
2 pi, 4 pi, it keeps on going. So phi will be equal to 0, 2 pi, 4 pi, it keeps on going like this. So if I have to condense this and write it as a single expression, I write it as 2n pi, where n belongs to the set of integers. n belongs to a set of integers because you can have minus 2 pi, minus 4 pi, minus 6 pi also. Okay. So what I'm trying to tell you here is, first listen, then you can write. Wherever the two waves are meeting in such a way that the phase difference between both the waves is exactly 0 or 2 pi or 4 pi or so on, when it is exactly equal to 2 and pi, at that point you can find maximum intensity, means those spots will be bright image, and that kind of an interference where the waves are superposing to give you a bright image is what is called as constructive interference. So this is the condition for an interference called constructive interference. So why do we call it as constructive? Because it is giving a maximum output. Right? So in the other hand, what will we have for intensity to be minimum? So for intensity to be minimum, for the intensity of the resultant to be minimum, what should be the value of cos phi? So cos phi should take the least value, and the least value of cos phi is minus 1. Right? So for intensity to be minimum, cos phi will be equal to minus 1. Okay. So when I say cos phi is minus 1, then phi can take all odd multiples of pi. It can be pi, 3 pi, 5 pi, so on. So pi, 3 pi, 5 pi, so on. So what will be the value of phi? It will either be 2n plus 1 into pi or 2n minus 1 into pi, where in both the scenarios the n belongs to integer set alone. So why I mentioned both the scenarios is, here it doesn't make much difference. Okay. Whereas in the other part, that is when we are going to discuss the next concept, that is Young's double slit experiment. At that point, you need to apply it. I'll tell you which of these two is to be used at which place. So as of now, concentrate. Since I told it is an odd multiple of pi, what is odd multiple? Even number plus 1 is an odd number. On even number minus 1 is also an odd number. That is why I wrote both this. It's a point here. This is a very, very important point. I'm telling you, this is where people make mistake. Okay, so make a note of this point. Right. And this kind of a situation where the intensity is getting nullified. So these at this place, right? Whenever the phase difference between the waves is an odd multiple of pi, means if one is like this and the other is like this, right? You get a dark spot. And this kind of an interference is the counterpart of constructive, which is called as destructive interference. It's called as destructive interference. Is it clear? Make a note of it. Finish. Right. So I hope you guys have made a note. So this is, listen to last statement. This is the condition for phase difference in terms of constructive and destructive. Those who are online, I hope you're clear.
Yes, sir.
Okay, we'll wind up.
Thank you, sir.